Bismillahirrahmanirrahim. Today we are going to see the work done for different processes. Okay. At first we have isobaric process. As I told you yesterday that bar, this is something related to pressure. Okay. Something related to pressure. So isobaric process means equal pressure process, or we can say the pressure will remain constant. So pressure constant. Throughout the process, we have to consider the pressure is constant. Now, if you take a look at figure 1.2, that is in your book. Let me draw the figure here. Okay. And as you can see, okay. So this is the figure given. Now, definition: the thermodynamic process in which the pressure of the system is not changed is known as isobaric process. We already know about this. Now, let us go through the explanation and see how to calculate the work done in this case. Let some gas is enclosed in a cylinder. As you can see, this is a cylinder. Some gas is enclosed here, right? Acha, fitted with a frictionless piston. We do not have any problem with the piston thing, but we have an objection regarding the frictionless thing, right? Because whenever we move the piston up and down, we know that there is some friction going to occur between the piston and the wall of the container, correct or not? Okay, because they are in contact and one is trying to move over another. So definitely there will be some friction and some heat loss will be there. Due to friction, we know that heat energy is produced and some energy loss is there. But for the ideal case, we are considering that there is almost no friction. We can reduce the friction using the lubricant and others, okay? But for now, we will consider that there is no friction. It is a frictionless piston, okay? Achha. Now the area of cross section of the piston BA, the area of cross section, okay? The area is A. Let us consider this one, okay? Then if the pressure of the gas is P, then the force on the piston due to pressure will be PA. This is the force. Okay, how this is the force? In grade 10 already, grade 9 itself, I guess, we already studied that pressure is force on unit area. That is, pressure is equal to F by A. Now, if I want to find out the force, I will just cross multiply. So here F will be equal to P into A. Correct or not? So the force that is being applied on this one is F, which is equal to PA. This is the force. Okay, do not get confused with the pressure. This is the total pressure also, you can say. Force is actually a pressure on unit area. Okay. Achha. So then, now if an external force F equal to this force is applied on the piston will remain in the equilibrium position. We know this. We understand this, right? As the gas wants to expand, it is applying a pressure, okay, on it is applying a force on this. Now if I do not want the piston to move in this direction, we have to apply an opposite direction if I want to keep it in the equilibrium position. You see, a force is being applied in this direction. Now if I want to balance it, if I want to attain the equilibrium position, I must apply a force from the opposite direction. Okay, this is the scenario that I have to apply, but whether I'm applying, I will not apply. Okay, then what will happen? If I do not apply, due to the application of this force, the piston will be moving in this direction, correct or not? Okay, to attain the equilibrium position, we have to apply a force in the opposite direction, but we are not applying any force. So as a result, what will happen? Due to the application of this force, the piston will be moving in the rightward direction. Or if the piston, if I had kept in the vertical direction, then what would have happened? What would have happened? That the piston would have moved in the upward direction. Correct? Anybody is having any doubt? Please. I can see someone have joined, as named as ... Who is it? Who are you? If I do not get a response, I'm going to remove you from the class. So within 5 seconds, kindly respond. 1, 2, 3, 4, 5. Remove. Okay. So yes. So what we saw that a force is being applied in this direction, and as a result, the friction, the piston is moving. Okay. Now what will happen? We are considering that it has moved a very small direction. This is the previous position of the piston. This is the final position of the piston. So what is the distance that it has moved? It has moved a dx distance. Okay, a very small distance. So for this small distance, we can consider that the pressure has not changed at all. Almost. Somebody has written something in chat. Sir, no class, so I joined. Who are you? Oh, Imon. Okay. আচ্ছা ঠিক আছে, একটু দাঁড়াও, আমি ওকে মেসেজ করে বলি যে if he wants to join, then come to the next page, that is page number 12. Now let us consider that the gas expands, and as a result the piston has moved through a very small distance, that is dx. See, the previously this was the position of the piston, now this is the position of the piston, so this is dx. The displacement is dx. Since dx is very small, the pressure of the gas can be considered constant. যেহেতু খুবই আমরা কম ডিসপ্লেসমেন্ট নিছি, আমরা চিন্তা করতে পারি যে এটা হচ্ছে কি প্রেসারের কোনো চেঞ্জ হয় নাই, এই হালকা একটু ডিসপ্লেসমেন্টের জন্য প্রেসারের কোনো চেঞ্জ হয় না। তো তাইলে we can consider this one as isobaric process, right, where the pressure is being constant. If the external work done against the force F be dw, then what will be the work done? See, dw will be equal to force into displacement. Work is equal to force into displacement. Why I wrote dw instead of w only? Because very small distance, so very small amount of work will be done. If I am displacing a body by a very small distance, then what will happen? The work done will be very small. Okay. Acha. So very small amount of work equal to force into small displacement.
Sir,
হ্যাঁ বলো।
তাহলে অনেক কম অ্যামাউন্টের ফোর্স অ্যাপ্লাই হবে।
আমরা এটাকে আবার ইন্টিগ্রেশন করে বড় অ্যামাউন্টের ওয়ার্ক পেয়ে যাব। দেখো এখন অসুবিধা নেই। So here what we can see, dw, this is equal to force. Now force is equal to F into P into A, right? F equal to P into A. Dx. Now what we can see, this part. Can anybody tell me what is this? A into dx. What is this?
Volume.
This is the volume. Very good. Actually, this is the change of volume. How? See, previously this was the volume. Now this is the volume, right? If I show you, previously this was the volume of the gas, right? But now the volume has increased to this. So what was the change of volume? This part is the change of volume, right? This is the total volume now. This is the previous volume. So from final volume, if I subtract the previous volume, I will be getting what is the change of volume, right? So that change of volume, I can say dV. We know that E, it represents the change. If you remember delta V. Delta means change, but delta we use for a large amount of change, okay? But when we are having a very small amount of change, we replace delta by D, okay? So dV is the amount of volume change. So dV is equal to, can I write area into height? This is the height, right? This is the area A. Okay, this is the area A and into height. So I will be getting the volume of this one. So A into dx will give me dV. So I will replace the value here. dw will be equal to P dV. Understanding this line is very important. Do anyone of you have any doubt that how I got PdV from PA dx? Area into height is what? Area into height is volume. Okay. Anybody has any doubt?
No, sir.
Okay, very good. Let's continue then. Okay, if the volume of the gas changes from V1 to V2, okay, till now we were considering that the volume change has been very small, okay. Now we want to know what if the volume change is bigger, okay. Now we are considering that the volume, it was previously V1, now it has become V2. So what will happen? The work will be, see, this is the small amount of work. If I integrate it, what will happen? Differentiation and integration, they will cancel each other and it will become W only, right? So dW, I will replace the value of dW here, that is P dV. Now as you can see, D, it is with V, right? So we will put the limit of the volume. Dটা V এর সাথে এই কারণে ভলিউমের লিমিট বসাবো। I hope এটা তোমরা অলরেডি জানো, যেহেতু তোমরা ক্যালকুলাস করে ফেলছো ম্যাথমেটিক্সে। So at the bottom we will write the lower limit. Lower limit means the starting point. We started from V1 and up to what we got, V2. Okay, so we are expanding it from V1 to V2. Anybody have any doubt in this one? No. Very good. Now as you know, whenever there is a constant, it comes out of the integration or differentiation part, right? So if you remember, the process is known as isobaric process, so the pressure is constant here. So as a result, the pressure will come out and it will be V1 V2 dV. Okay, then from here what I can write, D, integration and differentiation, they will balance each other and it will become V. There is another method also through which I can show you that why there will be D only. Okay, I think it will be better to show you, or else you might get confused later that how I got D here. Now if you remember, for integration I already showed you this formula, x to the power n plus 1 divided by n plus 1. Remember this? Okay, now if I apply that one here, there is no, let's see, there is dx, so we have x. Now we have dv, but there is no d here. So if there is no v, what I can write, v to the power 0. No v means v to the power 0, correct? Because v to the power 0 will become 1 and it will be ultimately integration dv only. So from here what I can write, following this one, power plus 1. So power is 0 here, so 0 plus 1 divided by whatever the power is here, that will be here also. So here also 0 plus 1. So it will be v to the power 1 divided by 1, which can be written as ultimately v only. Anybody has any doubt how I got this v? No, sir. Okay, good. So continuing the calculation, you know that we have to replace the upper limit first, then minus the lower limit. আমি আসলে শিওর হতে পারতেছি না যে তোমরা এগুলা ম্যাথমেটিক্সে প্রপারলি পড়ছো কিনা। পড়লে কিন্তু এগুলো আসলে আমরা তো এক্সপ্লেইন করতে হওয়ার কথা না। ওকে, সো এরপর তোরা কিছু করছে না, এরপর আর কিছু করে নাই। সো এই জিনিসটাই তোরা দেখেছে ডেল ভি হিসেবে। ডেল ভি, del V means the change in volume, if you remember. Delta means change and V means volume. So the change in volume. This is what V2 minus V1 represents. So this is the equation to calculate the work done throughout the isobaric process. Okay. So during numerical problem, these things are going to come handy. Okay. These things will be very useful. Whenever you see that for this 5 seconds, the pressure was kept constant, this information should click in your mind that we have to use this equation to calculate the work done. What will be is equal to pressure into change in volume. Okay. Now this one I can explain you from the pressure versus volume diagram also. If you remember, we talked about the indicator diagram in the last class. We talked about the indicator diagram. So from the indicator diagram, we can understand that this is actually going to be the work done. How? Let us see. So along y-axis we used to take pressure, and along x-axis we took volume, right? Now if the pressure is kept constant for isobaric process, the pressure is kept constant. That means, you see, let us say that initially our volume was V1 and we increased our volume to V2. Okay, the volume has increased, but what is the pressure? Oh, the pressure is still the same, right? See, with the increase of volume, the pressure is neither increasing nor decreasing. It is remaining constant. right? That is how the PV diagram should be for isobaric process, right? The pressure will not change; it will remain constant. It doesn't matter whether you increase or decrease the volume, correct? Now, if you remember, also we said that whenever we have a PV diagram, if I want to calculate the work done, I need to calculate the area under the curve. So we are considering the process from V1 to V2. If I want to calculate the area under the curve, how I can calculate the area? How? Does it look like a rectangle? It does, right? It does look like a rectangle. So how to find out the area of a rectangle? Length into breadth. Okay. So let us consider this is the length. So what is the length? This is the pressure, right? So length is pressure. Now the question arises, what is the breadth? This is the breadth. Now how to find out this breadth? If you take a closer look, this is the value of V1. And up to here it is V2. This total amount is V2, this is V1. So if I want to find out this, I can write V2 minus V1. Can I write it?
Yes.
Can I say that this is V2 minus V1? Definitely I can do, right? The total is V2 and this is V1. So from V2, if I subtract this V1 part, then I will be getting this length, right? And that is what the breadth of the rectangle is. So V2 minus V1. So P into del V. Okay? Is it clear now?
Yes, sir.
Okay. Nobody else is responding. Why is it that? Ritu.
Sir,
Jaman bolo.
sir, বুঝছি
আচ্ছা ঠিক আছে ঋতু বুঝতে পারছো আব্দুল মাজিদ তামিনা
Yes,
sir.
আচ্ছা ঠিক আছে কোনো ডাউট হলে বলিও কিন্তু আর মাঝে মাঝে একটু রেসপন্ড করিও যে ইয়েস বুঝতে পারছি একদম কিছু না বললে লাগে যে তোমরা ঘুমাই গেছো তো প্লিজ মাঝে মাঝে একটা আওয়াজ করে জানাই হচ্ছে স্যার জাগি আছি আমরা আমার কাছে এইসব জিনিসগুলো অনেক ইন্টারেস্টিং লাগে জানি না তোমাদের কাছে কি লাগে অনেকের কাছে বোরিং লাগতে পারে তো আবার তোমরা ঘুমাই যেতে পারো okay acha now we know that the first law of thermodynamics is dq is equal to du plus tw. Now for isobaric process we will rewrite the equation and how it is going to be dw. We have found an expression for that is pdv. So whenever we are applying first law of thermodynamics for isobaric process, we will write this equation dq is equal to du plus pdv. Okay, for isobaric process. So the similar equations and we are going to find out for three more processes, that are isochoric process, isothermal process, and adiabatic process, inshallah. So let us move to isochoric process. Let me ask someone of you. Mariam, can you tell me whether what is kept constant in isochoric process? Saud, what is kept constant in isochoric process?
Volume.
Sir,
Yeah?
Volume.
Volume, very good. Volume constant. Now this brings us to a very interesting point. Okay, the volume is constant. What will that mean? We considered that the gas is enclosed by a piston, right? Now when the gas the gas is applying some force on the piston, and as a result the piston is moving. So if the piston is moving, then the volume will change. But what if we keep the piston here itself? The volume is not changing. The volume of this space will never change unless this piston moves. These three sides are fixed. What if we keep this piston also fixed? Then what will happen? The volume will not change. Only that time the volume is going to be constant. If this piston moves, the volume is not going to be constant anymore. So for this process, we have to consider to keep the volume constant, this piston cannot move from its place. Now, if the piston is not moving, what is the amount of work done? Let us think about it in this way. According to physics, we know that sleeping, sitting, only standing in a place is not work. If we want to say that we have done some work, we have to apply some force, and due to that force, there has to be some kind of displacement. Like if I keep pushing this wall or the whiteboard for eternity, I am applying some force, right? But there is no displacement. I cannot say that I have done any work according to physics, right? So as there is some gas inside, it will be applying some force on it. The force is there. But if the piston is not moving, there is no displacement. And if there is no displacement, can the gas say that it has done any work?
No.
তাহলে work done তো zero হয়ে যাবে।
The work done will be zero here. Okay, because there is no displacement. Remember this one. Okay, whenever we say that we are considering the process to be isochoric one, we will say that the work done is zero, because in constant volume process the piston is not moving. The gas is applying some force on it, but the piston will not move. How we will keep the piston in equilibrium position? By applying an opposite force. So as a result, what will happen? You see, if there is an object, I am applying 5 Newton force from this direction, another 5 Newton force from that direction. As a result, what will happen? The forces are acting on the object, but no displacement will occur. As no displacement is occurring, what will happen? Nobody can say that any work has been done. So this is the similar case. As there is gas inside this container, force will be acting, but we are not allowing the piston to move in that direction by applying an opposite force from this direction. So both the forces are balancing each other as the magnitude are equal to each other, like this case, and the directions are opposite. So they will be nullifying each other. As a result, these two forces will not have actually any effect on the piston. So the piston will remain in the equilibrium position, the piston will not be moving. So there is application of force, but there is no displacement. So if there is no displacement, there will not be any work done. Also, we got to know that the work done is equal to, or we can say in this way, W is equal to P into V2 minus V1. Now, if you notice, there is no change of volume. There is no change of volume. Then what will happen? P into 0, because V2 minus V1 is 0. Previously, the volume was V1. Now also it is V1, because I did not change. So the change is 0. If you do not understand, or you are having difficulty in understanding this, I can give you a practical example. Today you went to market and saw the price of the shirt is 5 taka. Tomorrow also you went to the shop and saw the price is 5 taka. What is the change of price? 0. The price did not change at all, right? So this is the case what we are talking about here. Okay, previously the volume was V1, now it is also V1. The volume is constant. I'm saying it repeatedly so that it stays in your mind. Okay, the volume is constant, the volume is not changing, so the change of volume will be 0. So as a result, P into 0 will give us 0. That means the work done here is going to be 0. So if I rewrite the first law of thermodynamics for isochoric process, it is going to be like this. See, du plus dw, that is 0. So dq will be equal to dw. This is the equation for first law of thermodynamics in case of isochoric process where the volume is kept constant. Anybody has any doubt? No, there is no doubt. MashaAllah. Okay. Now, we are trying to understand all the work done through the graphs also, right? Now, can you think how the graph is going to be, or how the graph is going to look like in case of isobaric process? Isochoric process. The volume is kept constant. If you remember, we take pressure along y-axis and volume along x-axis. So the volume will be kept constant. Then what will happen? The graph is going to be like this. When the pressure was constant, it was like this. But when the volume is constant, it is like this. How would we understand that the graph is going to be like this? You can think about it this way. Let us say at first the pressure is P1. This is isochoric process. So there is no condition like that. The pressure has to be constant. The pressure can change. So at first the pressure was P. Now if I increase the pressure to P2, you will still notice that the volume is still P, the same volume. Okay. So now if I tell you find the area under the curve, do you find any area? This is just a single line. A single line does not have an area. Whenever I tell you to calculate an area, there has to be an enclosed space. Okay? Let us say, may it be circular, may it be rectangular, or any shape, or triangular. There has to be an enclosed area. But if I give you a line only, let us say I did not give you any enclosed area, a line only. Is there any area at all? There is no area. So the area under the curve is equal to the work. There is no area, no work. Understood?
Yes, sir.
বুঝলে সবাই একটু কষ্ট করে নিজেকে আনমিউট করে ইয়েস স্যার বলিও, তাতে আমার একটু এনশিওরিং মনে হয় যে মানে তোমরা বুঝতে পারছো এন্ড আই ক্যান মুভ ফরওয়ার্ড। তোমরা কেউ যদি কিছু না বলো তো সেখানে আসলে আমার কাছে ম্যাক্সিমাম সময় এটাই মনে হয় যে তোমরা আসলে শুরু থেকে কিছুই বুঝো নাই। এই কারণে তোমরা যে হ্যাঁ বলবা না বলবা, আবার কোনো কোশ্চেন জিজ্ঞেস করবা, কি জিজ্ঞেস করবা, কি বুঝছো কি বুঝো নাই, তোমরা কিছুই জানো না। ঠিক আছে? তো না বুঝলে at least কোশ্চেন জিজ্ঞেস করো, তার তাইলে অন্তত বোঝা যায় তোমরা ক্লাসে মনোযোগী আছো, কিছু বুঝার চেষ্টা করতেছো এবং মানে আসো আর কি তোমরা। আর নাইলে মনে হবে জাস্ট জয়েন করে ঘুমাইতেছো। আচ্ছা, so this is isochoric process. The next we have isothermal process. Isothermal process, the calculation is a little bit longer. Do we have enough time to discuss that? Uh-oh. We have class till 11:40, right? Only 3 minutes left. So no problem. Inshallah, we will talk about this isothermal process in the next class. I will request you to go through the isothermal process calculation a little bit so that it becomes easier for me to explain and easier for you to understand in the next class. Okay? And please be responsive during the class, because I see many of the time you are not responding. I'm confused whether you understood or not, and many time is being lost. Okay, so please respond immediately whenever I ask you any question. Thank you very much for joining. Prepare for the next class. I also have another class in 2 minutes. See you in the next class, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. And if anybody needs the video of this class, I have recorded, so knock me personally, I will give you.